Hello Year 9, we are going to be doing our second lesson now, so linear inequalities. So if you weren't listening for the first one, you'll be listening to my voice over the next few weeks while I take you through the mathematics that you are going to be required to do in the next few days. So let's get stuck into it. Linear inequalities. So an inequality or an inequation is a mathematical statement that uses the signs less than, greater than, less than or equal to, or greater than or equal to. Probably noticed the first mistake is that greater than or equal to should actually be this way, not the other way, but yeah. Okay, so the equal to has a little line underneath it and the other ones don't. So some examples of inequalities include 2 is less than 6 and 3x plus 1 is greater than or equal to 7. Okay, so we're going to look at how we represent these now. So we use a number line to represent the inequalities, as there is an infinite number of solutions for many inequalities. So like if I'm looking for numbers bigger than 2, well, there's 3, 4, 5, 6, and so on. You get the picture. I'm not going to sit here and count all the numbers. Otherwise, by the time I finished, we'd probably be back at school. So when we draw these on the number line, we use an open circle when showing less than or greater than. So if it's just those ones. So if we have a look over here, we've got x is greater than 1. So we put a circle where the 1 is and then draw an arrow pointing to the direction of the other ones. Okay, that's all that means. And then less than, so this one here, the second one, less than, we've got our example, x is less than 1, so we put a circle, an open circle on the 1, and we're pointing to all the numbers that are less than 1, okay? So all numbers are less than 1. Okay, and we use the closed circle when showing the other one, so when it's less than or greater than, less than or equal to, or greater than or equal to, then we're going to use this it's going to be the exact same thing, except with a closed circle instead. So if you have a look at here, we've got x is greater than or equal to 1, so you've coloured in the circle this time, and then you draw your arrow across. Okay, and the same for the other one too. We've got x is less than or equal to 1, so we colour in the circle for 1, and then we point all numbers that are less than or equal to that 1. So because we're including the ones in that one, that's why we circle it. And if we're not including it, we put the circle around it. Okay, so we can also have an upper and a lower bound on an inequality. So it's not just numbers that are bigger than and going into infinity. It's not just numbers that are smaller and going to infinity. We could actually include both. So here's an example of negative 2, which is less than x, but x is less than or equal to 3. So effectively, if x is in the middle, okay, you're talking about all the numbers that are in the middle. So negative 2 is less than x, so open circle on negative 2, just like there is there, and effectively an arrow pointing upwards because we want the numbers where x is actually the bigger number. Okay, so remember too, the way that we point these is it's always pointing to the bigger number, or it's pointing to the smaller number, or the shark eats the bigger number, as I remember it from my time at school. And then our last bit says x is less than or equal to 3. So colour in because it's equal to at the 3, but then we want the numbers less than, and we draw the arrow that way. Okay, and because we have because we have two intervals facing each other and going towards each other, we effectively just connect the two lines between the two dots. Okay, and that's it there. So notice the open circle on -2, but closed circle is on the 3. Okay, pretty simple. So linear inequalities may be solved in similar ways to linear equations. So we might give you something that looks like an equation that has an inequality sign in it to solve, and that's what you will be doing. You'll be solving it just like a regular equation. The only difference is if we multiply or divide by a negative, it flips the sign. So if I'm getting the x by itself and I have to remove a -2 by multiplying it, so it's -2 times x, and I have to divide by -2 both sides, it's going to flip the sign. Okay. So the reason why we do that is if we have a look at just some numbers, 5 is less than 8, as we all know, but if I put a negative on both of them, then I get -5 is actually greater than -8, so it actually flips the sign around when I do that negative. So if negative x is greater than 1, then x would be less than -1, okay? So it just flips that sign around. So that sign becomes that way when we put a negative or when we change our number from a positive to a negative, or vice versa. If we swap the signs of an inequality, then the sign swaps directions too, okay? So this basically means if I've got something on the lines of 3 is less than 7, okay? So if I swap the numbers positions, then the sign has to switch directions too. So 3 is less than 7, but that also means that 7 is greater than 3. So that sign in here has flipped the direction that it is facing. Okay, so if 2 is greater than x, then that just means that x is less than 2. Okay, so it's just a quick way of getting some number, or getting an idea of what those inequalities look like. Okay, so our examples for today show the following inequations on a number line. So x is greater than 5. So we're going to start off by drawing a number line, and our middle point is going to be the point where we're going from. So it's 5. Okay, so if we're looking for the numbers that are greater than 5, okay, we're not including 5, so I'm going to do an open circle, and then I'm going to draw an arrow pointing to all the numbers that are bigger than 5, okay, because we want all the numbers that where x is greater than that. Okay, so we've got 5, 6, and 7 versus the 3 and 4. So obviously, if we want numbers that are bigger than 5, we're going to be pointing towards the right. Okay, x is less than -3. So again, we're going to start off with a number line, okay, and we're going to start at -3, so with the numbers -4 and -5 this way, and -2 and -1 this way. So remember, for negatives, the order is reversed. Okay, so x is less than or equal to -3, so if it's equal to -3, we're going to have to circle on -3, but then if it's less than that number, then we're going to draw our arrow to the left. Now, -2 and 4, and x is in between the two, but it includes -2, but doesn't include 4. So what we're going to do is we're also going to draw a number line for this one. Okay, so we might start at -3, -2, -1, 0, 1, 2, 3, 4, and 5, just to identify that the numbers do keep going. They don't just stop there. Okay, so we're going to start at -2, and we are including -2 this time, so we're going to circle that dot there. Okay, now because x is from -2 to 4, okay, at the 4 we're going to do an open circle because we're not including the 4 in this case, and then our line just connects between the two, just like that, and so that one is a little segment. Solve the following inequations. So c minus 6 is greater than or equal to 5. So what we're effectively going to do for this is we're going to solve the equation as if it was c minus 6 is equal to 5. Now you guys have been solving these one-step equations since year 7. And it's pretty easy. We know the opposite of -6 is +6, and we get c is equal to 11. Okay? We're going to pretty much do the exact same thing, except without having an equal sign between the two, it's going to be a greater than or equal to sign. Okay? So we do the same thing, +6 on that side, +6 on that side. Okay? What we do to one side, we do to both. That leaves me with c on the left-hand side is greater than or equal to 11. Okay? And you can test that with some numbers. So what's a number that's greater than or equal to 11? Hopefully you come up with 12. If we put 12 in there, 12 minus 6 is equal to 6, which is greater than 5. So that is a true statement. Okay, next we've got 5x plus 3 is less than or equal to 23. So this is just a two-step equation, two-step inequality. So it's the same sort of thing, just with 2 steps this time. Okay, so we're going to do it the same way. We're going to subtract 3 from both sides, and it's going to leave it with 5x is less than or equal to 20. Then we're going to divide both sides by 5 and get x is less than or equal to 4. Okay, and those are our answers. Okay, let's go to the next slide. So we've still got some more inequalities. Okay, this time a little bit different. You'll see why in a sec. So we've got 3 minus 2x is greater than -5. So I need to get rid of this 3 first. Now remember, we use the sign that's in front of the number. So if there's nothing there, it's actually a plus. So the opposite of +3 is -3. So I'm going to write -3 and -3. That leaves me with this part here. So the minus and the 2x on that part is greater than -5 minus 3, which is equal to -8. Okay, I'll just rewrite that again, but just a bit further underneath. So -2x is greater than -8. Now we're going to divide both sides by -2 because that's what we've got. We've got -2 times x. So the opposite of timesing by -2 is dividing by -2. So -2 divided by -2. So that leaves me with x, and -8 divided by -2 is 4. But because we've divided by a negative, we need to switch the way that the sign's facing. So because -2x is greater than -8, then x must be less than 4. Okay, so let's try a number and see if it works. We know that 0 is less than 4, so if we put 0 back into our original equation, 3 minus 2 times 0, so 2 times 0 is 0, so 3 minus 0 is equal to 3, is greater than -5, and that works. Perfect. Okay, part B, -3m minus 5 is less than or equal to 22. So we're going to do it the same way. We're going to start off by adding 5 to both sides, and we get -3m is less than or equal to 22 plus 5 is 27. Now we're going to divide both sides by -3, divide by -3, and that leaves us with m is, now remember, because we're dividing by a negative, we're going to swap the direction of the sign. So m is greater than or equal to 27 divided by -3 is -9. And that gives me my final answer. 3 is greater than or equal to -9. Okay, so solving some more inequations. As you can tell, this chapter is mainly about inequations and solving inequations. Whoop, one too many. Okay, so this is just a regular one. So what we're going to do first is we add 2 to both sides. So plus 2 plus 2. This leaves us with x over 3 is greater than or equal to 7. Okay, now we've got x divided by 3, because remember, when it's a fraction, it means divided by. So the opposite is times by 3, times by 3. So that gives me x is greater than or equal to 7 times 3, which is 21. Okay, and the next one, whoop. Let me fix up this one a bit so I can actually fit it on. So if I do times 3 here, times 3 here, that leaves me with x is greater than or equal to 21. Okay, x minus 6 over 3 is less than 21. So again, it's the same thing. We're going to start off with removing. Now we're going to remove the bottom first. So whenever everything is on top of a fraction, the thing that you want to move first is the thing that's on the bottom. So we've got x minus 6, and that's all being divided by 3. So the opposite of that is to times everything by 3. Okay, so that leaves us with x minus 6 is less than 12 times 3, which is 36. Now we've got x minus 6 is less than 36. Okay, so the opposite of minus 6 is, of course, plus 6. I'm getting a bit ahead of myself. Plus 6 and plus 6, and that leaves us with x greater than, or sorry, x is less than 36 plus 6, which is 42. So there's my 2 answers for those ones, okay? So again, it's just like doing a equation, a regular equation. There's nothing different except the symbol that's in between the two, and that sometimes it flips. Solve the following inequalities. All right, so we've got 3 lots of x minus 6 is less than or equal to 10. So doing this one, we know how to solve. Well, let me ask you this. Do you know how to solve this one? So if it's an equals instead. If you answered yes, awesome. If you answered no, it's pretty much the same as what we're about to do, but that's okay. What we're going to do is we're going to multiply 3 by x, and then the 3 by minus 6, okay? So whatever's on the outside, you multiply everything on the inside. So 3 times x is 3x. There's a minus in the middle, so I put my minus in the middle, and then 3 times 6 is 18. And that needs to be less than or equal to 10. Okay, now we just solve this like a 2-step equation. Opposite of subtracting 18 is adding 18, so I add 18 to both sides, and that leaves me with 3x is less than 28. Okay, then to get rid of the 3, we're going to divide by 3, and that leaves me with x is less than or equal to 28 divided by 3 is, of course, 9 and a third. Okay, so we can still have fractions as our answers for these, or decimals. You can have it as a fraction or a decimal, doesn't matter, it's up to you, but 9 and a third is more than correct. Oh, and again, it seems like it loves it when I can't even do this, so I'll draw a line. So x is less than or equal to 9 and 1/3. Okay, now our last bit, or next bit, we're going to multiply everything by -2. So we multiply this, and we're going to multiply this, and we are going to then multiply this through to get -2t. Okay, now minus 2 times 3 is equal to -6, and that needs to be greater than or equal to 8. Okay, the opposite of minus 6 is plus 6, so plus 6 and plus 6, and that gives us -2t is greater than 8 plus 6, which is 14. Okay. Now t, so to get the t by itself, we need to divide by -12. Divide by -12. 12? What am I doing? Getting ahead of myself again. Divide by -2. Divide by -2. So that leaves me with t is greater than, so 14 divided by -2 is -7. So is that the correct answer? No, of course not. We forgot to flip the signs. Remember, whenever we times or divide by a negative, it's only when we times and divide, but whenever we do, we need to flip that sign. So t is less than -7 is our final answer. Solve the following inequalities. And I have a feeling this might be our last lot. Yeah, it is. All right. So, solving the following inequalities. Now, this one looks a lot like 3a minus 6 equals 2a plus 4. And you guys would be able to tell me what we do first. And that is we're going to move all the pronumerals to one side and all of the other numbers to the other. Now, the way we're going to do this is we're going to look for which side has the most amount of pronumerals, and we're going to move everything to that side, or we're going to move all the pronumerals to that side and everything else the other way. So we'll start with the pronumerals. I've got 3a on this side, and I've got 2a on this side. Which side has the most? Hopefully you said the 3a. Okay, so I'm not looking for just individual a's, I'm looking for... So remember, 3a just means a plus a plus a, and 2a just means a plus a. So which side has the more a's? And so it is this side here. Okay, so we're going to do this side. I'm going to move the 2a over. So the opposite of 2a is minus 2a. So we can actually do minus 2a on both sides. And what that does is it removes this one here, but then I get 3a minus 2a on the left-hand side, which just leaves me with a. 3a minus 6 is less than or equal to, or less than 2a plus 4. So it leaves me with a minus 6 is less than 4. And now this is just like a one-step equation. To get rid of minus 6, I'm going to add 6 to both sides. I'm going to get a is less than 10. Okay? And so that's our answer. Now I have a sneaky suspicion there's probably going to be one that pops up right on top of that. Okay, I'm going to just move it all up. A is less than 10. Okay, that's my final answer. Okay, last one. So 5a minus 2 is greater than or equal to 2a plus 10. Okay, so start off with your pronumerals first. So I've got 5a's on the left side, 2a's on the right side, so the opposite. Well, what I'm going to do is I'm going to remove the 2a's from the right-hand side, and I'm going to by subtracting 2a from both sides. So that leaves me with 3a minus 2 on the left-hand side, and that leaves me with 10 on the right-hand side. Okay, the opposite of minusing 2 is adding 2, so add 2, and that leaves me with 3a is greater than or equal to 12. Dividing both sides through now by 3, and that leaves us with a greater than or equal to 4. Okay, so that's pretty much how we do all these inequalities. My suggestion would be to do this. We started at question number 1 and 2. So my theory would be go back through, watch how I did 1 and 2, and then go back and then go to where we were or where we finished, and then actually do questions 1 and 2. Then go back and have a look what I did for question 3, okay, and then look at questions for 3. Then go back and look at how I did 4, and then come back and do 4, and so on and so forth. Just that way, it gets you so you go, okay, this is how I do these ones. Now I can go and do these ones myself, okay? But with that being said, that's the end of this video. And please let me know how you went, okay? Now, we are expecting this work to be completed every time that you do have maths in class. So make sure it gets done, okay? And we will be checking the work that you are doing at the end of the week. Ciao.